Okay, today I'm going to discuss one of the past year question. Actually, this question I get it from the SAS Buddy past year question. I think this is the question for 2012 for paper 2 transformation. This is of course transformation we know is for modern maths. Alright, I think it's a form 5 chapter 5 if it's not mistaken. Alright, so over here I'm going to do the full demo how to solve the transformation chapter. But before I start to solve this question, I think some of the students might confuse about what is the meaning for combined transformation. So let me give some brief explanation on the combined transformation. Okay, you will see combined transformation in paper 2. Okay, for example, I just randomly give some example. T is translation, and R is reflection, and okay, and yeah, maybe L is enlargement. Okay, this is just an example. Okay, whenever you see combined transformation like this, you always see something like this, T square. T square means actually you perform T 2 times. If you got the translation is something like 2 negative 3, means 2 negative 3, 2 is mean moving to right hand side 2 unit, negative 3 mean moving down 3 unit. So that means you move 2 times. So you will have translation 2, 3, so you will have 2, 3, and then 2, 3 again, 2 unit, 3 unit, 2 unit, 3 unit. Means actually you do the same translation 2 times. This one means T square. Okay, but sometimes you will have something like TR in your exam. Okay, when you got something like TR, remember this one. Always perform the transformation behind one first. Okay, if let's say this is the first one, this is the second one, always perform the second one first. Means what? Means you have to do the reflection first. After reflection, then only you do translation. Alright, if you got RT, means what? Means you have to perform translation first. Then only you perform reflection. Alright, this is something some student always gets confused because he said TR. Some student might do the transformation T first, then only R. That's wrong. Because we always need to perform the transformation at the behind one first. Mean we have to perform T first, then only R. Okay, if you got LR, so we know we have to perform R first. Then only we perform enlargement. Alright, this is some basic understanding about combined transformation. Alright, so I'm going to start about this question. Okay, actually this question is quite simple, and I choose a simple questions to make you understand the way of solving this kind of question. Alright, so first you will see some graph over here. Okay, actually this one I draw according to the diagram. Okay, then A, it says a transformation T is a translation for 2, negative 1, and R is the rotation. R is an anti-clockwise rotation of 90 degrees about the center C. So he got the center C over here, and then R is rotation. And then actually got some information I'm missing, so I write again. And then he give you P actually is the reflection on the line y equals to 2. Alright, so normally I solve the question like this. What I will do first is I will write down some information the question give. Like what? Like you say A actually is a translation, and not A. T is a translation 2, negative 1. And then I know R actually is the rotation, and then we got anti-clockwise, rotation, anti-clockwise. So you must know what is the direction for anti-clockwise. Anti-clockwise, your clock we turn like this, right? So anti-clockwise means in this direction, called anti-clockwise. Okay, so at the center, anti-clockwise 90 degree, at the center T, 90 degree, about center C. Okay, center C. Alright. Oh yeah, center, I write again. Center C. Alright. And then we got another one is P. P is a reflection on the line y equals to 2. Okay, I write some short form just for myself to understand. Alright. Then I will start to do part A. What he says, state the coordinates of image of J under the transformation T. Okay, so first, you can have a look on J is over here. So first one, he wants, okay, this coordinate, of course you must know what is the coordinate for J. So I do some remark here. J actually located at, J is like 9, 3. This is 9, 3. This is the coordinate for J. Okay, so first one, he asked for what? Translation. T is a translation to -1. So that means, okay, so for first one, so we have to find the image of J. So to -1 means actually move 2 and then -1 go downwards 1. Alright, so you can do something like this. The J image maybe will equals to, okay, 2 means actually plus 2 for x, minus 1 means actually minus 1 for y. So actually you will locate this as 11, 2. Okay, if you understand, you can do like this. If not, you just make sure this is 1, 2, and then go down 1. The coordinate over here is 11, 2. So I got 11, 2. So it's the same thing because I say this one is moving on the horizontal axis. So normally I will say moving on the x-axis. This one is moving on the vertical axis. So I say we're moving on the y-axis. So obviously the 2 will affect the x over here. And then the -1 will affect the y. Alright, so you can understand this one like this. Yeah. Then, what is TP? Alright, the second one is TP. I say if you got T and P's together, we always perform P first. We perform P first. So what is P over here? P is a reflection on the line y equals to 2. So where is the line y equals to 2? This one is the line y equals to 2. Okay, I use the red markers to actually draw y equals to 2. Okay, this equation called y equals to 2. Alright, so that means the J going to reflection down, so the J image will somewhere over here. This one will be J image. So actually you can see if from here reflects to here. And then after reflection, he going to do the translation again. So will be 1, 2, 1. So he will go to this one. Okay, because 2 for x and -1 for y. So what is the coordinate for this one? It's very simple. You will get the coordinate is 11, 0. Okay, so normally this is the way to solve the combined transformation. Of course, you can write like this, or the other way, you can write like this is something like this. Okay, if you, for this one, you want to do combined transformation TP, you can do the first one, J is equals to 9 and 3. Okay, so he performed the first one, he performed what? He performed P first. So P actually give it the coordinates. What is the coordinate after reflection? He give you the coordinates is 9, 1. Okay, so he will goes to the 9, 1. Alright, let me see. 9, 1. What is the P again? Transformation. P is a reflection on the line y equals to 2. Y equals to 2. Reflection. J will reflection. Yeah. He will give you 9, 1. However, and then you're going to perform translation. Translation actually will give you from 9 ones goes to the 2 units, 1 unit he will goes to the 11 0. You go to the 11 0. Alright, this is the combined transformation over here. However, I'm not sure why my answer is different with the answer in the textbook. Oh, I know why. Because I just write the question wrongly. Because actually, in the questions, is transformation P is a reflection and the line y equals to 12, not y equals to 2. Okay, so let us do again. Okay, if P is y equals to 12, I'm going to write this straight line again. Okay, this one is equals to y equals to 12. How I know? Actually, it's very simple. You can see this is 12, right? So y equals to 12. This equation called y equals to 12. So if I reflection, you can see this is J, right? Okay, J is from 9, 3. Okay, you have to know from 3 to 12 is 9 units. So if I reflection, I will go 9 units above, because from here to here is 9 units. So I'm going to go another 9 units above. So I will go to the 21 9. So it's 9 21. So in this case, this one will be 9 21. So because this coordinate is located on 9, so even it reflects, it will remain at coordinate 9 for x. It will only moving on the y. So because here is 9 units, from 3 to 12 is 9 units, so the j actually will move another 9 unit go up. So 12 you plus 9 is 21. So I will go to 921, and then only I do the translation. Translation is very obvious. Translation is 2 negative 1, mean we plus 2 for this one. Plus 2 from 9, I will got 11, 20. And then minus 1 for y. Plus 2 for x, minus 1 for y. This means 2 negative 1. Alright, so I will got 11, 20. Okay, this is answer for the second one. And yeah, of course, the last one, what he asked for P and R. So let me take another paper. Okay, we're going to do P and R. Okay, P and R, we know which one should we perform first. We have to perform rotation first. Alright, then only we goes to the reflection. Okay, for rotation, so first this is J, is located at what coordinate again? J is original is 9, 3. Okay, now if I perform R, I'm going to rotate. What is R? R is the rotation anti-clockwise 90 degree. Okay, so now you see from here, and this is center point. If I rotation anti-clockwise 90 degree, the coordinate methods mean from here I have to rotate like this, form a 90 degree on C. So my J image will add here. So you see, actually this is 90 degree on the middle. From here I rotate 90 degree, I will go to the J image to here. So what is this coordinate actually? This one actually is 7, 5. Okay, so my first J image will goes to the 7, 5. It's very simple. You can see actually here is a 90 degree. Okay, it's a 90 degree. Okay, if I draw the 90 degree, the C will be missing. Okay, let me draw a C for this one. Okay, so actually you can see here is 90 degree, rotate up. So he will locate it as 7, 5. Alright, then only I perform P. P is a reflection on this line. So this one, so when I do the reflection, I will go up somewhere over here. So I have to calculate how many units from 5 to 12 is 7 units. So I'm going to go up 7 units. I will go to 12, go up 7 units is 19. So it's 7, 19. 7, 19. That's all. Right. Yeah, of course you need some understanding on how to do the rotation. Yeah, and then how the reflection actually reflect, because coordinate reflection is coordinate actually is very simple. If the coordinate is over here, you're going to reflect to here. So you need some basic understanding on the rotation and reflection. I think rotation for coordinate is simple also. Yeah, make sure here and here is the same length, and then you got the 90 degree on the coordinate C over here. Okay, alright, so now we've done the part A. Okay, we're going to go to the part B. Okay, part B, what the question actually asks is, M is the image of, okay, he said M is the image of K. So this one is the image, this one is the object. Alright, under the transformation, under the combined transformation, WV. So when WV, I know actually is perform V first. If you perform V first, then only W. So we have to see how this one actually goes to the M. So it's very obvious. This one actually he do the reflection to L, and then he do the enlargement to M. So from here at least I get some basic information is V is something, because you do V first, right? Something related to the reflection. And then W is the next transformation, is of course is enlargement. Alright, so this one you really need to understand, because do not have any specific ways to actually teach you about this one. So impossible is enlarge first, then only he do the reflection, because he purposely give you a L over here. So sure with the reason why L is over here. So actually you can see this one and this one actually they are something like mirror. So you have to find the lines of mirror. So obviously if you are good enough, I think you can straight away find the mirror actually is located somewhere over here. So you can see this is the mirror. Okay, what is the straight line for this one? This straight line we call x equals to A, because it's touched at A. So if you got this one is the mirror, so this one reflect to this one, yeah, it makes sense. So, but then he asks you describe in full, so you have to do some describe in full. So the first one I know V, okay, B, A. Okay, I will say V is a reflection. V is the reflection on the line. What is this line? X equals to A. Yes. Because reflection is very simple. As long as you tell reflection and tell the reflection line, then should be fine. After that, VW, right? So I know the next step is W. So W is actually he enlarge. After he goes to the L, actually he start to enlarge. So enlarge, we need few information. One is we needs to know about skew factor, and then we needs to know the enlargement point. Yeah. So we have to find, okay, skew factor is very easy. You can calculate like this. This here is 1, 2. So here is like 1, 2, 3, 4. So this is image, right? Image divided by object 4 over 2. The skew factor is 2. Alright, you can do like this, or some students might do not like this way, or you can find a center point first. Okay, find a center point, I said very easy. Like each coordinate you connect to the other coordinate, you can easily find. So, okay, let me do some connection. So this one, this one, this one. So roughly the enlargement point is somewhere over here. So I will trying to connect them. Okay, okay. This coordinate connects to the same coordinate, connects to the same things. Alright. Alright, I randomly connect 3 of the coordinates, see whether we can get a intersection coordinates or not. So, from the 3 coordinate actually I connect, I found out that all of them actually touch at the point 14, 0. They touch at 14, 0. So from here, I get some information. The enlargement point is 14, 0. So after I got this one, what I'm going to do is, because he said VW, so what I know at least is W is something related to enlargement. So I'm going to write W is a enlargement, and then enlargement of, we have to know what is the skew factor. Of skew factor, what is the skew factor? Okay, you can do like this. You calculate the translation from the center point to the image divided by the and then you use the translation from center point to the image divided by the translation for center point to the object. Okay, this one will be slightly more works to do. Okay, it's something like this. Okay, for example, I take this point. It's like 1 and then 1, 2, 3, 4, 5. Okay, 1 and then like x equal to 1, y equals to 1, 2, 3, 4, 5, 6. So this is 1, 6 to this coordinate. So I'm going to calculate how long I take to here. So this one I roughly sketch over here is 1, 6. Okay, it's 1, 6. So I calculate to here. It's like 1, 2, and then this is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 2 and 12. So obvious, so you can know if you take 2 divided by 1, you get 2. 12 divided by 6, you got 2. So the skew factor is 2. So W is an enlargement of skew factor 2, and then with the center we just find, with the center 14, 0. Then you will get all the 4 marks. Alright, so of course this kind of question you really need some basic understanding on what is the meaning for, he say combined transformation VW. Object go to image, he got 2 transformation. Of course we perform V first. So V is the object reflects to here. You have to find reflection line. And then W is the enlargement. So after you reflect here, he's going to enlarge. So enlargement, you need to find skew factor and center point. Okay, after you get these 2, then you have to write everything in the sentence. Of course, in order to get mark, you have to say translation, reflection, and then which is the line, which line is the reflection line. And then for the enlargement, you have to mention is an enlargement, and then what is the skew factor, and then what is the center point. Okay, you need all this information in order to get the full mark. Alright. Okay, last is this one. Okay, it says given that K represents the regions of area. Okay, K represents a regions of an area 12 centimeters square. Calculate the area in m square of the region represented by m. Alright, this question means what? You have to know the relationships between the... Okay, so K represents, so he tell you this area is 12. And then he asks you calculate the area in m square. So for this one, you must able to know the formula for, in this chapter, I say area of image will equals to K square. K here is not this K, K here is a skew factor. K here is a skew factor square multiple with the area of object. Okay, you need to understand about this formula, then you can easily solve this question. Alright, so we do not have area of image, so I write the I stand for area of image. But then I know the skew factor for enlargement. Just now we mentioned is 2. So 2 square multiples area of objects 12. So this obviously is 4. So the area for image is 4 multiples 12. We got 48 meter square. We are done. You will got 3 marks. So this 3 marks is very easy to get as long as you understand this formula. I'm not sure this formula is given or not in the exam, but as what I know, it seems like not given. So it's not hard to remember actually. Just I equals to K square multiple O. Mean area of image equals to skew factor square multiple areas of object. Then you can get the full mark for this one. Alright, so I hope this full demo video actually gives you some insight on what is the combined transformation and what happens when the coordinates rotation or reflection, and why he will stay at A if he will stay as the x-axis when he reflects to the on y, on the lines y, and then how to find the center point and everything lah. So I hope this video really can help you. If I got time, maybe I will do more videos on transformation, but actually this chapter is very hard for me to teach in the videos, but I just do my best. Anyways, hope you enjoyed the video. Thanks for watching.